concept is equilibrium of four-force system. Last class we have discussed about the three-force system or a member with a three-force, and the previous class we have discussed about two-force members and equilibrium or static equilibrium definition, right? Okay. This class we are going to discuss about the equilibrium of four-force member. Move on to the problems. Okay, right. So let us consider a body is applied forces. Okay. Now, what will be the condition for the start? Write down a system of a system of four non-parallel forces, a system of four non-parallel forces, system of four non-parallel forces non-parallel forces a system of four non-parallel forces acting on a body acting on a body acting on a body acting on a body in which P, capital P, is the point of intersection of P is a point of intersection of forces F1 and F2, forces F1 and F2, and Q, capital Q, is the point of intersection of forces F3 and F4, F3 and F4, full stop. Now join point P and Q. Join point P and Q, comma, the resultant of forces F1 and F2, the resultant of forces F1 and F2, the resultant of forces F1 and F2, and the resultant of F3 and F4, resultant of F3 and F4 must be parallel to PQ, must be parallel to PQ and opposite to each other, must be parallel to PQ and opposite to each other. Please copy this figure.
Just madam. ये मत और ले
Harshit Pujari. Copied? Okay. See, let us consider this is F. Sorry, this is F3. This is F4. Okay. F4. This is F1 and F2. Okay. See, there are four forces are acting on a body, and let us consider F1 and F2 intersecting at a point. This point is P, intersecting at point P, and F3 and F4 are intersecting at a point Q. If you join P and Q, we'll get a straight line. We'll get a straight line, and the resultant of F1 and F2 and the resultant of F3 and F4. Okay, so these two forces are always parallel to PQ, and both are opposite. See, this is the resultant of 3 4, and this is the resultant of 1 2. These two resultant forces are always parallel to PQ, and it is opposite to each other. So if this condition is satisfied, then you can say it is in a static equilibrium condition. It is in a static equilibrium condition. That's all. Is it okay? Okay. So let us go to the next concept. I hope you copied. Okay. So next is analysis of single slider tank mechanism. This is very, very important because we are moving on to the problems. Okay. So problem number 1, copy this. Problem number 1, analysis of single slider tank mechanism. Under that, if problem number 1, there are two types of mechanism: single slider tank mechanism and 4-bar chain mechanism. In this module, we are going to solve some problems on these two mechanisms. Okay, single slider and 4-bar chain mechanism. Please copy this figure. Copy this figure. (60°), and the force applied on the slider is 1000 Newton. Okay, this point is C. Yeah, that's all. This much data is given, and we have a torque that is, I don't know the direction of torque, but it is given as T2. T2 torque 2. Am I audible, Mr. Namrat?
Yes, sir.
Are you following or not?
Following, sir.
Okay. Vikit Hegde? Vikit? Hello, Vikit. Am I audible? Shall I remove you, Vikit? Yashwant R. Yashwant R. Harshit. Hello, Vikit. Am I audible? Harshit. ಹರ್ಷಿತ್
ಎಸ್ ಸರ್.
ಎಷ್ಟೆಲ್ಲ ಕರಿಬೇಕಾ ನಿನ್ಗೆ?
ಸರ್ ಸ್ವಲ್ಪ ಹೊರಗೆ ಹೋಗಿತ್ತು ಸರ್, ತಿಂಡಿ
ಯಾಕೆ ಹೊರಗೆ ಹೋಗುದು ಪಾಠ ಮಾಡುವಾಗ?
ಅದು ಸ್ವಲ್ಪ ಕೆಲಸದವ್ರು ತಿಂಡಿ ಕೊಡ್ಲಿಕ್ಕೆ.
ಆಯ್ತು, ಹಾಗಾದ್ರೆ ಮೂವ್ ಮಾಡ್ತೀನಿ, ಕೆಲಸ ಮುಗಿಸ್ಕೋ.
ಆಯ್ತು ಸರ್. ನಂದು
ಗಾಂಚಾಲಿ ಮಾರ ನಿಮ್ಗೆ, ನೀವು ಎಷ್ಟು ಗೊತ್ತಾಗುದಿಲ್ವಾ ಅಷ್ಟು? ಹಾ,
ಚೂರ್ ಸರ್.
ಯಶವಂತ್ ಆರ್. ಚರಣ್.
ಸರ್.
ಸುಮಂತ್. Okay. Okay, I think you have copied the problem. This is what the problem. Given in the question paper, previous question paper, you can see this problem. Okay, here this is a single starter mechanism because there is a slider and the slider is connected to the connecting rod, and the connecting rod is connected to the crank, right? So here we have 1000 Newton force acting on a slider along the horizontal direction. Now we need to find out the value of torque, direction, and the magnitude of torque, driving torque. Is it okay? So here this mechanism is to the same principle of this single slider crank mechanism, but here is going to find out the driving torque. So if you apply the torque on the crank, automatically the slider will move. So this will be used to push the heavy loads. Here the load applied is 1000 Newton, and we need to apply a torque T2 torque on a crank, so that will be transferred to the piston. The piston will move, or it will help us to move the heavy load which is in front of piston. Okay, so this is what the working principle of this single slider crank mechanism. It is a reverse of IC engine. Okay, the concept or the working principle is same, but the work done will be on piston by applying a torque on crank. But in the IC engine, the power will be generated in the piston and that will be transferred to the crank. So that is the reverse of this one. Okay. Oh. So whatever it may be, but the concept or the working principle is same. Okay. So this is what the given problem. Now here, yes, given 60° from IDC crank. This is the crank. AB is a crank. Crank is 60° with IDC, inner dead center. Inner dead center. See here, we have a piston cylinder arrangement. We have a crank here. This crank is rotating like this. And if you connect this crank, so this is what the center line. Okay. Now, inner dead center is this one. This is outer dead center. Or it is called as top dead center. It is a bottom dead center. Top dead center or bottom dead center. So this angle from the inner dead center. So when the point O is at this point, then we'll have inner dead center. The angle will be 0. Slowly it moves like this and it makes an angle of 60°. That is given in the problem. Is it okay? Okay. Now, the first step 1, write down. Step 1, solution. Step 1, okay, In the step 1, we need to draw the given mechanism with scale. Okay. Here, this problem, continue this problem. Dimensions are also given here. AB is equal to 100 millimeter, and BC is equal to 300 millimeter. Okay, please copy this. It is not given in the problem, but it is given in the problem. Okay, I have not written. AB is equal to 100 millimeter and BC is equal to 300 millimeter. You need to have a drawing instruments, please. Many of you have drawn balancing of rotating masses first module, freehand sketch. It is not acceptable. You have uploaded, some people have uploaded the same thing. Few of you have not submitted till now, not submitted. Okay, I know what to do at the end of the semester. And this module also have a drawing with a scale. Okay, it is not a freehand sketch. You need to draw with a scale and pencil. Okay, with actual scale. If you do a freehand sketch, okay, freehand sketch not acceptable. I'll put absent for all the classes. Okay, and I am going to create an assignment every day, day by day. For each and every problem, I'm going to create assignment. You need to upload the scanned copy of your problem, whatever I have solved in the class. Okay, right. Okay, so AB length is given, BC length is given, an angle of ABC is given, that is 60 degree. Now you can draw the scale, or you can draw the figure with actual scale, right? Okay. Draw the mechanism with the scale. So how to draw this mechanism? First one, you draw an horizontal line. Horizontal line. See, I'm going to draw the horizontal line. Okay, so exactly horizontal line. Please take the scale and drawing instruments. Okay, horizontal line with a dotted line. Next, mark a point somewhere here. Okay, this point is A. Okay, so A, and AB length is 100 millimeter, right? 100 millimeter. You need to take a proper scale. I'm going to take a scale here. Write down scale. So the maximum length is 300 millimeter. 300 millimeter means 30 centimeter, right? Now what scale you are going to take? 50 millimeter is equal to 1 centimeter. Yeah, 50 millimeter is equal to 1 centimeter will be the proper scale, right? Okay, 1 centimeter is nothing but 50 millimeter scale, because 300 millimeter means will be 6 centimeters, right? Okay, so AB is 100 millimeter means 2 centimeters. Now what is the angle? Angle is 60 degree. Take 60 degree. 60 degree. Okay, after taking the 60 degree line, take the compass and take 2 centimeter, because AB is 2 centimeter, means 100 means 2 centimeter. So cut the length. B. Manjunath R is there?
Yes, sir.
Copied?
Yes, sir. Copying, sir.
Okay. Do you have drawing instruments?
Yes, sir.
Okay, very good. Advait Menon,
Yes, sir.
drawing or not?
Yes, sir.
Okay. Siddharth,
Yes, sir.
drawing?
Yes, sir.
Sujit. Mr. Sujit.
Yes, sir.
Okay.
Yes, sir.
Sushant. Okay. Next, what next? Next is BC length. BC length is 300 millimeter. BC length is 300 millimeter, right? AB is 100. If you convert that into scale, 2 centimeter, BC length is 300 millimeter. According to the scale, it will be 6 centimeter, right? 6 centimeter. Take 6 centimeter in the compass and cut the length. Cut the length. So we'll get a point here. This point is C. Right? Join these 2 points. We'll get a line or connecting rod. This is what the connecting rod. Right? And we have a piston in this point C. You can take a piston of any length, no problem, or any width. Not an issue. Join this. And the piston is always moving inside the cylinder. You can represent the cylinder like this by taking any length, no problem. Okay. Now the force is acting on the cylinder is thousand Newton. It is equal to P. Okay. Let us take the force as P. Finished? See, I'm going to create assignment after completion of each and every problem in this module. If you are able to submit it on that day only or within the scheduled time, then only you can attend the next class. Otherwise, I won't send a link to you. Those are not submitted the answers. Okay. Please remember. Next. Finished? Hello. Now, after finishing this figure, you need to give a link, numbers to the links. Okay. So this is a fixed link, right? You need to show the fixed symbol. Fixed link. Okay. So how many links are there? There are 4 links, right? The fixed link is considered as link number 1. This is link number 1, fixed link, or fixed link. Link number 2 is this one, 2. This is 2. Link number 3 is this one, and link number 4 is a slider, right? Or a piston. Piston is considered as link number 4. Now we have a torque here. This is applied torque. It is given in the problem. This is T2. T2. Giving numbers to the link, you might have already studied in the kinematics of machines, right? Numbers to the links. All fixed link is considered as a link number 1. Link number 2 is a crank. Link number 3 is a connecting rod, and the link number 4 is what? Piston. Finished? Abhishek Patil, finished?
Yes, sir.
Loyal, finished?
Yes, sir.
Okay. Mohammad Yasin. Mohammad Yasin.
Yes, sir. Finish, sir.
Okay. Let us go to the next step. Okay. Step 2. Step 2. Actually, this module, people will think it is a very difficult module. But if you know the concept, or if you follow the same procedure, what I'm going to follow, it will be very, very easy. Otherwise, it will be complicated. If you are not able to concentrate on this, or if you are not able to follow the steps, it will be difficult. Okay. Okay. Next, step 2, free body diagram. Free body diagram. Free body diagram. Now, what we are going to do is, we are going to open all the links and we are going to show the forces on each and every link. Okay. Okay. Let us consider the first body is link number 2. Okay, link number 1 it cannot show because it is a fixed link, right? It cannot say, or it cannot take any particular dimensions for the link number 1. It is a fixed link. It is a body of the engine that is considered. Okay, you forget about link number 1. Link number 2. Okay, so take the link number 2 of the same length. Okay, same length or any length, no problem. I'm going to take a link number 2 of same angle. Okay, first you need to draw a link number 2, 60 degree, right? It should be almost 60 degree to horizontal line. You just mark horizontal line and take a 60 degree. Okay, so that 60 degree, no need to show. You just show the link number 2. This is link number 2. Okay, if you have a roller scale, it will be easy, and take length of 2 centimeter, approximately 2 centimeter. It is not a problem. Should not take, you don't need to take actual scale, but you need to take a scale, actual scale, this figure. Okay, yeah, this free body diagram, no use of the actual scale. Okay, next, now what are all the forces acting on this link? Okay, so okay, we'll keep it as it is, link number 2, and torque is acting here, that is T2. Okay, that is the first link. Now you come back to the second link. Second link is, second link is over. The third link is connecting rod, right? I'll draw connecting rod somewhere here. I'll just open this links, all 3 links, okay? And I'll draw. So this is what the link number 3. Link number 3. Okay, link number 3. Just open the system, that's all. Draw it separately, all the links. Okay, so this is what A, B, this is C, sorry, B, C, correct? Next, which link is there? Link number 4. Link number 4 is here. Is a slider, right? Link number 4 is a slider. Link number 4 is a slider, and this point is C, correct? Point C. And here, let us take this as link number 4. Okay. And what is the force acting here? This is point force, that is P, correct? This is what? P. P is equal to 1000 Newton. It is given in the problem. This is what the free body diagram. But I have shown the links and link numbers and the points, and I have shown the given forces. That's all. But I have to analyze the forces because here there are hidden forces also. In the static equilibrium, let us consider the system is an equilibrium. All the bodies or all the parts or all each and every element will be in equilibrium, right? If the system is in equilibrium, each and every elements of the system will be equilibrium. So I have opened all the elements and I have to show the forces. I have shown only two forces. One is P 1000 Newton, another one is torque T2. But I don't know the magnitude of T2. I need to find out. Okay, that is the question. Now I have not shown any force on link number BC, and I have not shown any other forces other than P on link number 4, and I have not shown any forces on AB link number 2 other than T2. Correct? All of you copied? Draw it neatly. Take your own space. Okay. I need to show some forces also on this figure. That's why I have given enough space to that. Okay. Is it okay? All of you copied? All of you copied or not?
Yes, sir.
Very good. Next. If you're not copied, I can give you more time. Please, it is a very first problem. I cannot go fast. It will be very difficult for you. I need to go very slowly. If you want to have some more time to copy this, I can give you. Please don't hesitate. Okay. I hope you finished. Next, I need to continue with this one. Free body diagram. So the problem, the 50% of the problem is depending on this free body diagram. If you draw the free body diagram, if you show all the forces on the free body diagram correctly, then the problem will be easy. Otherwise, the problem will be difficult. You'll be stuck in between. Next step. Okay, step number 3. Okay. We have step number 2, free body diagram. We have drawn the forces of 3 elements, right? But first link, it is a fixed link. You cannot draw it. Okay. You need to identify, while showing the forces, we need to identify the link where we have a known forces. In which link we have a known forces? Which link of these 3 links we have known force? Please, can anyone tell? Mohammed Gauss. Mohammed Gauss.
Yes, sir.
Can you tell me the link which is having the known force out of these 3 links?
AB.
AB link. Do you have any known force in this link?
Sir, C. Force.
Link number 4 is having a known force, that is P, correct? Here T2 is there, but T2 is unknown. That is a
1000
question,
Newton.
right? Yeah. P is an unknown, known force, that is link number 4. Okay, you come to the link number 4. You forget about link number 2 and 3, okay? You just leave it. Link number 4. Now, I have reached to link number 4. I have a force P, that is 1000 Newton. 1000 Newton. You come back to the previous diagram. Yeah, link number 4 is here. We have a link number 4 and P is applied on the link number 4. Now, I have a link number 3. Link number 3 is connected to the link number 4 and it is meeting at a point C. Now, if you apply the force in this direction, in the left direction, some amount of force will be acting by the link number 3 on link number 4, right? Correct? If you push if you apply the load in this direction, automatically the resistance force will be acting on the opposite direction by the link number 3. Yes or no? This is very, very important step. There is a force acting on link number 4 by the link number 3. Correct? There is a force acting on link number 4 by link number 3. If you apply the force if you apply the force P on link number 4, that I'm going to show. See here, this is what the force, look at this. This is the force acting on a link number 4 by link number 3. Link number 3. So, and this force is parallel to this line, okay? It should be parallel to this line, the direction of force. So this force is F, 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 3, 4. F34. What is the meaning of F34? Force by link number 3 on link number 4. Okay. So this number indicates from which link. This number indicates on which link. That is force by link number 3 on 4. Any doubt in this? Next, one more force is there. See here, we have one force in this direction, another force is in this direction, and we have a fixed link, link number 1, and the slider is sliding over the link number 1, right? There is upward force. Look at this. So this is what the upward force I'm going to show. This is what upward force, vertically upward. This is called as F. From which force? From which link? Link number 1 on link number 4. Any doubt you can ask? Because I have connection with two different links, link number 3 and link number 1. So from these two links, I have a force that is F34 and F14. Any doubt? Shall I explain it once again?
Yes, sir.
Showing the forces. Okay, very good. See, I had only P on this link, right? Link number 4. So link number 4, if you go back to the previous slide, link number 4 is connected to link number 3 as well as link number 1. Because link number 1 is a cylinder or a fixed link. It is sliding over the link number 1. So there is a force, upward force by link number 1 on link number 4. And we have one more force. The link number 3 is connected to link number 4. There is a force acting by the link number 3 on link number 4. F34 and F14. Correct? That I have shown here. F14, it is exactly vertical, and F34 is along the direction of link number 3. Any doubt?
Frictional force.
Yes?
Frictional force.
You just,
Frictional force, sir.
yeah, you just neglect the frictional force. Why? Because the self-weight of the piston and the frictional force we are going to neglect because we have applied 1000 Newton force. If you compare the frictional force and applied force, the frictional force value is very, very less, very, very small. That's why we are not going to consider while analyzing this. Is it okay? We are going to consider only the applied forces. Any doubt? Otherwise, the system will be complicated, and so it will be a very lengthy if you consider the frictional force and self-weight, everything. Is it okay? Who is this? Hello, who is this? Very good question. Okay, let it be, no problem. So very good question he has asked, why the frictional force is not considered, right? Very good. So this is the end of the link number 4, finished. Now you come back to the link number 3. Okay, reverse. Next, you jump to the link number 3. Because I have a force link number, force F34. I have to convert the same force to the link number 3. Look at this. I am going to do it. If the force is acting on link number 4, that is F34, this is the force by link number 3 on link number 4. The same amount of force will be acting on link number 3 by link number 4. See, this is the force. I'll show it. This is the force. It is opposite to this one. This is the parallel, okay? F, here the name is different, but the force is same. F4, link number 4 on link number 3. On link number 3, that is F43. It is very easy, correct? So if you know this force, you just write the same amount of force here by changing the numbers. That's all. Because I'm considering link number 3. So that's why F4. The force due to link number 4 on link number 3. Any doubt? Doubt? Now what is the direction? Direction same as the direction of F34. F34 direction is BC, and F343 is also parallel to link number 3. Along the direction, okay, it is a straight line along the direction of BC. See, I told you in the previous case, this is parallel to link number 3, right? If this is parallel, and automatically this is also parallel to this one, equal and opposite, okay? This force is equal to this force, and this force is opposite to this force. That's all. Because every element is in static equilibrium. Okay. Finished? Hello.
Yes, sir.
Okay. Now, what is the condition for a body with a two-force system? One force is acting like this. Let us consider this is F43. Now, what will be the other force? It is equal and opposite, correct? Equal and opposite, that is F. I'll see. Now, what is the other end? Other end is BC. Let us consider this is C, okay? This is B. Where is B? B is here. He is telling that same amount of force will be acting on point B, but it is equal and opposite. Opposite to the force. Opposite to what force? This force, F43. Now, what is the name of that force? This force is F. Where is the point B? B is here, right? You come to consider the previous link number 2. Point B is a common point on link number 2 and 3. Correct? 2 and 3. Now, this force is acting by link number 2 on link number 3. Because point B is a common point on link number 2 and 4. Sorry, 2 and 3. Now, what is the magnitude of F23? F23 is equal to F43. Correct? Equal and opposite. Then only the system will be in equilibrium. It is a two-force member. Which one? Link number 3 is a 3 is a two-force member, right? What is the condition for two-force member? If if the body is applied by two force, these two force must be equal and opposite. These two force must be equal and opposite. That is understood. Any doubt? If you have any doubt, I can explain it once again. Why it is F23? Because point B is a common point on link number 3 and 2. So, if some force is acting on link number 3, that is only due to link number 2. That's why F23. F23. Force by link number 2 on link number 3. The method of reading is like this. Force by which link? On which link? So, force by second link on link number 3. So, the naming of forces are very, very important. Finished? Finished? Hello?
Yes, sir.
Yes. Next. Any doubt? If you have any doubt, please ask me. Don't worry. I can explain it once again. Okay. Next, see, I have a force F23 on link number 3. The same amount of force will be acting on link number 2. Because one force is acting on link number 3 by link number 2. The same amount of force will be acting on link number 2 by link number 3. Is it okay? Okay. So the point B is acting by a force F23 on link number 2. Point B is acted upon the same amount of force, but it is opposite to what? Opposite to F23. This is F32. The force by link number 3 on link number 2. Any doubt in this? Any doubt? F32. Force by link number 3 on link number 2. And it is equal and opposite to this force. F23 is nothing but F32, but opposite in nature. Finished? Hello? Finished? Aitendra? This should be parallel to this one, okay? You know, yellow parallel forces. Equal and opposite. Finished? Next, I have one more force. Because, see the previous figure, link number 2 is mounted on a link number 1. There is a connection between link number 2 and 1, right? There will be a force on link number 2 by link number 1. But I don't know the direction. I don't know the magnitude of link number 1. Force due to the link number 1. That is F. F. From which link? 1. On link, which link? 2. F1, 2. I don't know the direction. I don't know the magnitude. That's why I've shown in a zigzag way. That indicates I don't know the magnitude. I don't know the direction. Baki all forces, we have all other forces with the direction, but magnitude is unknown, of course, but directions are known. But this force F12, I don't know the direction, I don't know the magnitude. Why it is F1? Because link number 2 is connected to link number 1. The force due to link number 1 on link number 2. If you have any doubt, please ask me before going to the next step. Copied? Hello? Hello, copied or not?
Yes, sir.
Any doubt? Anybody have any doubt? I can explain it once again if you have any doubt. Otherwise, I'll proceed. Okay. See, I have link number 4, link number 2, link number 3. Correct? All three forces or all three links. I have shown all the forces, right? I have shown all the forces directions also. Some forces are having a known magnitude, known direction. Some forces are always having direction, but I don't know the magnitude. Some forces are unknown magnitude and unknown direction. So I have to solve this problem. Let us consider First, we need to take the link which is having a known force. Which link is having a known force? The link number 4 is having a link of known force. Next step 3. Step 3, calculation. First one, step 3 Ali. First step 1. Consider link number. Consider link 4. Link 4. See, the link number 4 is having 3 different forces. 3 different forces. You know, the body or the member with 3 forces. See here, 3 forces system. What is the condition for the 3-force system is in equilibrium? Can anyone tell? ಈಗ ಕಾನ್ಸೆಪ್ಟ್ ಅಪ್ಲೈ ಮಾಡಬೇಕು 2 force member, 3 force member and 4 force member, or 2 force with 1 torque member. These 4 concepts you need to apply. That's all. Okay, 3 force, a body with a 3 force member or equilibrium of 3 force member. What is the condition? First condition, resultant force must be equal to 0. That is summation of forces. All the forces must be equal to 0. Correct? And the line of action of forces intersect at a common point known as point of concurrency. We'll have a point of concurrency, and summation of all the forces must be equal to 0. Summation of all the forces must be equal to 0 means what it indicates? The force polygon must be closed. Force polygon must be closed means we need to draw the force polygon. Force polygon. See, let us draw the force polygon for link number 4. Okay? Yes. Link number 4. Link number 4. Consider the link number 4. Draw the force polygon. Force polygon. Force polygon. To draw the force polygon, you need to take a proper scale, right? Scale. So, what are the forces acting on this link number 4? We have 1000. The maximum force is 1000 Newton. 1000 Newton. Take what is the unit? What is the scale you are going to take for 1000 Newton? 1000 Newton. 200 Newton is equal to 1 centimeter. So 1000 Newton is equal to 5 centimeter. Okay. Okay. First one. P 1000 Newton. Take 1000 Newton. Okay. 1000 Newton. I am going to take 1000 Newton. 1000 Newton means 5 centimeter, right? Take 5 centimeter horizontal direction. Exactly horizontal. Correct? O A. What is this? P is equal to 1000 Newton. Direction towards left. What else is there? See here. One more force that is F14, but I don't know the magnitude. I don't know the magnitude, but I know the direction. Correct? I know the direction, but I don't know the magnitude. So direction means exactly vertical 90 degree. Take 90-degree line, draw one horizontal line. Okay. So I don't know the magnitude. F14. F14. I don't know the magnitude. I don't know the length. Next, for equilibrium, summation of all the forces must be equal to 0. Means force polygon must be closed. Next force. What is the direction of this force? So parallel to this line. Correct? You go back to this one. You just measure this angle. What is this angle? You check it. Can anyone tell me the answer for this angle? This angle? Can anyone tell me the answer or the angle for this angle? BCA or ACB? Can anyone tell me the angle from the step one? Step one, what is the angle? That's why I told you to draw this with actual scale, because we need to have an angle. ಯಾರಾದ್ರೂ measure ಮಾಡಿ ಹೇಳಿ angle. Can anyone tell me the answer? Please.
17 degrees.
Yes,
17 degrees.
70.
17.
17. Take 17-degree angle. Draw the line. We'll get an intersection point, right? 17-degree. Maybe may not be same. Please, can anyone another? Any other answer? Any other answer? 17-degree, correct? ನಾನು ಬರೀತೀನಿ ನೋಡಿ, 17-degree ಅಂತ ಬರ್ದಿದ್ದೀನಿ. You check the answers. 17-degree, you take the 17-degree here. 17. Right? And it will intersect here. This is 17-degree. From where? Angle BCA is equal to 17-degree from, from step 1. Step 1. So, what is this? This is F14. Correct? What is this? This is F. What is this? 3, 4. Now tell me the answer. Tell me the answer. This is A, point B, A. Okay. Therefore, below this figure, F14 is equal to length of what? AB into scale. What is the length of AB? Can anyone tell me the answer? This is scale 200 by 1. Can anyone tell me the answer for length of AB? F34 is equal to length of OB into scale. 2 centimeter?
Yes, sir.
Exactly 2?
Yes.
Yeah, 2 means 400 Allah. 400 Newton. OB length? OB length? ಬೇಗ ಟೈಮ್ ಆಯ್ತು. OB length. Devraj B is there in the class. Snehal is there. Snehal.
Yes, sir.
Snehal, why are you missing classes in between? You are not there for last four or five classes.
I was not well, sir.
Why? That's what I'm asking. I know you are not there for last 3-4 classes.
No, I was not well, sir. I had fever.
You informed to your class advisor or HOD?
No, sir.
Then how do you say you are not feeling well? Huh? You could have informed, right?
Yes, sir.
Is it possible to say, so I am not feeling well, so I am not going to take class for another 2 weeks? I have to inform somebody, right?
Yes, sir.
No, then. Okay, now tell me the answer for OB length. Can anyone tell me the answer for OB?
5 centimeters, sir.
Exactly 5 centimeter?
Yes, sir.
Exactly 5. I don't think so.
0.4.
Huh?
5.3.
5.2.
5.4.
Okay, 5.3, 5.4 is okay, no problem. I'll take 5.3, okay? So what is the answer? It should be always 5 greater than 5 because if you have a same answer, then it will be 1000 only, right? Newton, 1000 Newton. Answer. Correct now?
1060.
1000?
1060.
ಸರ್ ಹೇಳಿ ಆಯ್ತು ಮುಗಿತಾ ಬಂತು ಇನ್ನೊಂದು 10 ನಿಮಿಷ ಅಷ್ಟೇ ಆಯ್ತು ಇನ್ನೊಂದು 2 ನಿಮಿಷ ಆಯ್ತು ಸೊ 1060 Newton, correct? So F3 4 and F1 4 is there, correct? So I have this force and this force. Now you can easily find out F43. F43 is equal to F34. So F43 is also ready. F323 is always equal to F43. F23 will get. F32 is always equal to F23. F32 will get. So now we need to find out Ft2. So that we will do it in the next class. Okay. We'll continue. Save. Okay. Thank you. You can leave.
Sir, attendance, sir.
Attendance have taken.
Sir, 2 minutes late ಆಯ್ತು sir.